Hello everybody, my name is Sadiq Mehman. I am a solutions architect from Cisco Advanced Services. You can reach me either via Twitter or via LinkedIn. Today, I'm going to present you all managing Cisco's application-centric infrastructure, commonly known as ACI. The presentation will focus on demonstrating configuration and verification on a live ACI fabric in my lab. The agenda of today's presentation is to first go over my lab topology. I will then show you software upgrade process in ACI. Later on, I will demonstrate you how to configure management access in ACI, mainly configuring out-of-band management. Then, I will show you how to configure access control in ACI, mainly demonstrating configuring TACACS. Finally, I will show you how to configure SNMP, syslog, and NTP in ACI Fabric. So let's move on with the presentation. Cisco's ACI is a leaf-spine architecture, as you can see in my topology, with software controllers called APICs to program the fabric. APIC also allocate resources to various tenants and monitor the overall health of ACI fabric. In my lab topology, I have 3 spines, spine 1, spine 2, spine 3, 6 leaves, leaf 1, leaf 2, leaf 3, leaf 4, leaf 5, leaf 6, and 3 APICs, APIC 1, APIC 2, APIC 3, simulating ACI fabric stretched between multi-data centers, data center 1, data center 3, data center 2. ACI stretch fabric is nothing but a regular single partially meshed fabric in which one dedicates at least 2 leaves at a given data center as being transit leaf that have connections to all the spines in the fabric. Local leaves will have connections only to their local spines within their data center and does not need to connect to other data center spines, conserving cross-connect 40 gig links between data centers. Hence, one would require 4 40 gig links from each data center transit leaf to stretch between 2 data centers. For a 3 data center stretch fabric, the cross-connect links would be 4 times 2, that is 8 40 gig links from each data center transit leaves. Advantage of stretch fabric is ease of management in special design scenarios. However, you can either have stretch fabric design or a regular fully meshed single ACI fabric design. As you can see in my lab topology, I have dedicated leaf 2 as the transit leaf in data center 1 connecting to all the spines, with its local leaf, leaf 1, connected to its local spine, spine 1 in data center 1. Similarly, in data center 3, I have leaf 5 acting as a transit leaf connecting to all the spines in the fabric, with local leaf, leaf 3, have connections only to its local spine 2. In data center 2, I have leaf 6 acting as a transit leaf connecting to all the spines in the fabric, with local leaf, leaf 4, connecting only to its local spine in data center 2. I have 1 APIC controller in each of the data center 1, data center 3, and data center 2. There is no special configuration required for transit leaf. It's just the way physical connections within a fabric are made that transforms a leaf to become a transit leaf. I have 3 APIC controllers, 1 in each data center, APIC 1, APIC 2, and APIC 3. Now, this is not an ideal topology in a real production environment, as I have a single 40 gig link from local leaf to its local spine in each of the data center. Also, single APIC in each of the data center. This is due to limitation of hardware in my lab. For best practice stretch fabric design, one should consider at least two spines in each of the data center with local leaves connecting to each of the local spines in a redundant fashion. Also, one should consider having two transit leaves connecting to all the spines in the fabric in each of the data center for redundancy. Similarly, one should consider at least two APICs in each of the data center for redundancy. I have configured out-of-band management within ACI Fabric to reach out to syslog, SNMP, TACACS, and NTP server. I have also configured few collaboration servers connected to Leaf 1 in Data Center 1 and Leaf 4 in Data Center 2 using VMware. I have also configured two collaboration endpoints connecting through external network to these collaboration servers being hosted within ACI Fabric to ensure that my ACI Fabric is working and functioning properly. Let's move on to our first topic of software upgrade in ACI. There are three methods of upgrading ACI software. One, via APIC graphical user interface. Two, via command line interface. Three, via RESTful API. There are three types of ACI images. One for the APIC controller, the other one for the nodes, leaf and spine, and the third one is for catalog. The catalog image gets loaded when you upgrade the APIC image in most cases. However, in some special case, one need to install or upgrade catalog image separately. There are two options to download ACI images. One through HTTP, the URL is shown in this slide, and the other method is by using secure copy. Images are stored in the APIC's firmware repository and are synced to remaining controllers within the fabric. APIC controllers are upgraded serially, whereas nodes are upgraded parallelly. Default are 5 nodes at a time. That can be changed, and I'll show you later down in my presentation how to change that sequence. Nodes can be upgraded in groups through maintenance group. In a VPC setup, one node will be upgraded than the other VPC pair node. Here are some of the high-level steps for ACI software upgrade. First and foremost, you have to download the ACI software from Cisco's website by using your CCO ID. You should go through the release notes of the software first and foremost before upgrading your ACI Fabric. Download the image into the firmware repository of the APIC. Upgrade the software on the APIC controllers first, followed by upgrading the software on each of the nodes, leaf and spine. Finally, verify your software upgrade process. Now, I will perform the software upgrade process via APIC GUI. However, For those who are interested in performing software upgrade process via CLI, I have put down these steps here. So these are the steps to upgrade the software of ACI via CLI, mainly for APIC. These are the steps to upgrade the software of nodes via CLI. Also, if someone is interested in upgrading software of ACI via RESTful API, these are the steps to do so for APIC. And these are the steps to upgrade the software via RESTful API for nodes. I have downloaded these steps from Cisco's website that you can check out at your leisure. However, as I said, I will perform or demo you the software upgrade process using APIC graphical user interface. So let's move on to show you the actual software upgrade process in ACI using APIC graphical user interface. Let's log on to my APIC controller to upgrade the software. Let's first check the topology, what we have discussed earlier. And here you go. As I mentioned, I got 3 spines, one in each of the data center, and 6 leaves. Leaf 1 only connected to its local spine, spine 1. Leaf 2 acting as the transit leaf in data center 1, connected to its local spine, spine 1. And spine 2 in data center 3 and spine 3 in data center 2. Similarly, leaf 3 locally connected to spine 2 in data center 3. Leaf 5 is a transit leaf for data center 3 connected to all 3 spines. Leaf 4 locally connected to spine 3 in data center 2. Leaf 6 is acting as the transit leaf for data center 2 connected to all the spines. I got 3 APIC controllers, one in each of the data center. Okay, so let's see the current running software in ACI Fabric. For that, we have to go to admin, click on firmware. Let's check the controller current firmware. As you can see, currently the APIC controllers are running 1.13F. So we are going to upgrade it to the latest code, which is 1.21. So let's first download the code from the Cisco website. Here is the link that you have to connect to, and using your CCO ID, you have to download this APIC image, which is ACI-APIC-DK9.1.2.1k.ISO file that is used for the APIC controllers. You also need to download this code for your node software upgrade. Okay, I have already downloaded that on my client workstation here in my lab. So from there, let's upload it to the APIC. Before we proceed further, as I have shown you in my lab topology, that I have two collaboration endpoints connected to these collaboration servers, one in data center 1 and one in data center 2. So I just wanted to show you that these collaboration endpoints are working fine. As you can see, folks, both of my collaboration clients or endpoints were able to do or exchange messages via Jabber. Let's initiate a phone call between these clients as well. And here you go. As you can see, both the collaboration endpoints, users Sadek and Ahmed, are able to not only exchange IM messages, but they are able to communicate via Jabber phone service as well. Okay, let's move on to our software upgrade process now. To our software upgrade in ACI Fabric. As I just showed you, currently my ACI Fabric ACI APIC controller are running 1.13f software. Let's first bring the 1.2 code into the firmware repository. So here you go. I've downloaded it on my client workstation. And now I am uploading that firmware into the firmware repository. Let me pause the recording because it's going to take a little while. There you go, folks. The firmware upload is completed. It will take 5 to 10 minutes for the firmware to copy to the Apex before it is viewable in the firmware repository table. So let's click on OK, and we'll wait for a few time so that it will show up in the repository table. Let me pause the recording one more time. Okay, as you can see, the firmware is now showing up in the firmware repository. So let's upgrade the code on the APIC controller. As I mentioned earlier, the upgrade process takes one at a time with the APIC controller. You cannot configure any maintenance group or firmware group like what you can with the node software upgrade, which we will do right after we upgrade the APIC controllers. So let's first upgrade the APIC controllers. For that, we have to click on the APIC controller firmware tab. As you can see right now, it's running 113F. So right click on the controller firmware, or you can click over there and on the right hand side where it says action, click on upgrade controller firmware policy. Over here, you can now see this APIC 1.2 21K software that you just uploaded in the firmware repository. So select that code. You have the option to apply now or apply later, meaning you can schedule this firmware upgrade on the APIC controllers at a later time as well. Since we wanted to do it right now, we'll click apply now and click submit, and we'll follow the upgrade progress as it moves along. So let me pause the recording one more time. Alright folks, as you can see, the first APIC controller has just rebooted and we lost the connection to it. So we'll just wait for it to come back, or in the meantime we can connect to the other APIC controller and see what the overall status is going on. So let me pause one more time. Alright folks, as you can see, the APIC one just came back up and it is showing 1.2. Okay. However, the other two controllers are still in progress, and I can show you their status. APIC 2 is now 75%. I have connected to APIC 2 right now, and it is going in under software upgrade process. So we'll pause the recording one more time. Alright folks, APIC 2 is going under reboot process right now. As you can see, it's requesting timeout over the ping. So now, once APIC 2 comes back up, it will come back with the 1.2.1, and finally APIC 3 is now undergoing the software upgrade process. I have logged on to APIC 1 with the new code 1.2. As you can see, the GUI is fairly new than the previous one. So let me pause the recording one more time till the third and final APIC gets upgraded to 1.2 code, and I'll get back to you. And finally, APIC 2 came back up successfully with 1.2.1 code. And we are just remaining with the third and final APIC controller, APIC 3, which is undergoing the software upgrade process. In the meantime, I just wanted to show you that I have initiated a phone call between the two collaboration endpoints since I started the firmware upgrade process on the APICs, and as you can see, so far I have not lost the telephone communication between collaboration 1 and collaboration 2, Zarek and Ahmed phone calls. So let me pause one more time till APIC 3 completes with the software upgrade process. Alright folks, we now successfully upgraded all the APIC controllers, all the three APIC controllers in Data Center 1, Data Center 2 and Data Center 3. So now let's move on upgrading the nodes. So I have just created a firmware group and maintenance group for Data Center 1. Alright folks, for software upgrade on the ACI nodes, leaf and spine, I have created 3 firmware groups, one for each of the data center 1, Data Center 2, Data Center 3. Similarly, for maintenance groups, I have created 3 maintenance groups as per the data centers, Data Center 1, Data Center 2 and Data Center 3. Mainly to demonstrate to you that the software upgrade in each of the data center ACI nodes go smooth without disrupting any service. So data center 1 firmware and maintenance group consist of node IDs 101, 102, and 201. Data center 2 firmware and maintenance group consist of node IDs 103, 105, 202. And data center 3 firmware group and node maintenance group consist of node IDs 104, 106, and 203. I have already uploaded the latest code for leaf and spine in the APIC firmware repository that I can show you over here. As you can see, I have already uploaded the firmware in the APIC firmware repository for the nodes. So let's initiate the software upgrade process. I will demonstrate you doing a software upgrade right away for data center 1 and a schedule for data center 2 and data center 3.
Okay folks, let's start the upgrade on the maintenance group data center 1. Just do the upgrade now. We know what the 12 major faults are, so not to worry about it. Say yes. There you go. Initiated the upgrade process on the data center 1 node maintenance group. Let me pause the recording and I'll be back once it is done. Alright folks, as you can see, leaf 1 101 node ID and spine 1 201 node ID are in the process of reloading after the software upgrade. So we are waiting for those to come back. And we have noticed that leaf 102 in data center 1 has not been upgraded yet. It is still waiting for leaf 1 and spine 1 to come back and still be able to serve all the application servers within its maintenance group. So this is the beauty of ACI, that you can create maintenance group in each of the data center and still keep your applications running and serving the user community. So we'll wait for the leaf 1 and spine 1 to come back with the latest code, and after that leaf 102 will undergo the software upgrade process. Alright folks, as you can see, both leaf 101 and spine 201 and data center 1 maintenance group have been upgraded to the latest code successfully, and finally it is now conducting software upgrade on leaf 102 in data center 1 maintenance group, which was the remaining final leaf there. Let's check out the CLI. For leaf 1. As you can see, it is running code 1121. Let's check out on spine 1, 11.2. So cool. Let's wait for the leaf 102 to finish. We can also check the status of our collaboration client. So both the collaboration clients are still talking since we started the upgrade process. As you can see, they did not drop the connection. So your service disruption has not occurred during the software upgrade process in the ACI fabric because of the way you have configured the maintenance group in each of the data centers. So let's wait and monitor the Leaf 2 to upgrade its software and come back. Alright folks, we have successfully upgraded all the nodes in data center 1, as you can see, to the latest code 11.2.1. Let's check out Leaf 2 via CLI as well. And there you go. Okay, let's check if our clients are still talking to each other. And there you go, they are still talking on Jabber. So we did not disrupt any service during the software maintenance upgrade in Data Center 1. Now for Data Center 2 maintenance group, I have scheduled the upgrade instead of selecting upgrade now. So I have created a scheduler, as you can see, and it has also kicked in because the time have passed, and it has kicked in the software upgrade process in Data Center 2, and it has already completed 70 to 60% on Leaf 105 and Spine 202. It has not initiated software upgrade process on Leaf 103 in Data Center 2 to avoid any service disruption. So let's wait for this to finish up. Alright folks, as you can see, we have successfully upgraded both Data Center 1 and Data Center 2 maintenance group to new code 11.2.1. So now we're gonna upgrade the Data Center 3 maintenance group. This time we're gonna schedule this upgrade process. So let's click on Data Center 3 maintenance group. Okay, let's click on Action, create one-time window trigger. We can call it DC3 upgrade. Put the date today, and let's put a minute from now. Say OK. Maximum concurrent nodes, let's say 2, and maximum running time unlimited. Click Submit. Alright folks, as you can see, we have just created a scheduler to upgrade Data Center 3 nodes, and we have given a time a minute later from right now. So let's wait for it, and I'll show you it will kick in right after a minute from now. As you can see folks, it has already started upgrading Leaf node ID 104 and 203. already completed 5% from both of those nodes. So let's wait till it finish up, and I'll get back to you. All right, folks, let's confirm that all 3 data center nodes have been upgraded to the latest code 11.2.1, and sure they are. As you can see on the screen, let me put it on full screen. And there you go. All of them are showing 11.2.1 code. We can confirm the status of our client to see if they are working fine.
Alright folks, as you can see, I still have communication between Sadiq and Ahmed going on since we started our software upgrade process. So this basically concludes our software upgrade process in ACI. Let's verify via CLI that we have successfully upgraded the code in the ACI fabric or not. For that, you have to log on to one of the APIC controller. And run this command. There you go, folks. As you can see, it will give you the status of all the leaf and spine along with the APIC controllers current firmware version, which is right now showing 1.2.1K, which we just now upgraded it from 1.1.3F. So this concludes our software upgrade process of ACI Fabric. Let's move on to our next topic. Configuring management access. There are 2 methods of ACI management access. First, in-band management, that is considered to be the preferred one. Second, out-of-band management. In-band management access is through the fabric itself, whereas out-of-band management is through the management interface of APIC, spines, and leaves. Out-of-band management interface is just 1 gig link. So make sure if you are connecting your leaf and spine and APIC through out-of-band management to your external management network, make sure you connect it to a 1 gig interface. ACI management interfaces does not support IPv6. The out-of-band management of APICs is configured during the initial setup phase. I have cut and pasted the initial setup of APICs here on my screen that you can see. At this time, you have to input the out-of-band management IP address of your APIC one by one, along with the default gateway and the interface, speed, and duplex mode. In order for you to configure the out-of-band management for nodes, leaf, and spine, you go to the APIC GUI and configure that via following these steps that I have posted in this slide. So let's demo you how to configure that via APIC GUI. So let's log on to the APIC GUI to configure the out-of-band management. interface for the ACI nodes. Important thing to note here is that you have to use mode basic in order to configure the out-of-band management interface for ACI nodes. Once you get logged on to APIC GUI, click on the System tab. Under System tab, you'll see In-band and Out-of-band tab. Click on there, and then select Out-of-band Management Configuration. There you go, folks. As you can see, all my leaves and spines are already configured with the out-of-band management address along with their default gateway. However, if you wanted to configure it, you can click on this plus sign, choose your node, put the out-of-band management address along with the default gateway, and click update. So this is how you configure the out-of-band management interfaces for the ACI nodes. Now, if you recall, initially I have showed you to log on to basic mode. The reason why I mentioned that is that you won't see this in-band and out-of-band tab if you log on to advanced mode, and I'll show you that. Click on the admin tab, toggle GUI mode. Are you sure you want to switch to advanced GUI mode? Say yes. And see, you don't see the in-band out-of-band management tab over here in advanced mode. Alright folks, so this concludes how to configure the out-of-band management interface in ACI mode. Let's move on to our next topic. Alright folks, let's go over configuring access control in ACI. There are three methods of ACI access control. First, TACACS plus, second, radius, and third, LDAP. You can configure either one of these access control method or all of them together. I have put down some of the prerequisites for configuring ACI access control. ACI Fabric must be configured up and running in a healthy condition before you configure the access control methods. External authentication server such as TACACS, Radius, or LDAP must be configured and available to serve the ACI users. Create Cisco AV pair attributes and permissions on your external authentication servers. APIC management EPG needs to be configured. Here are some of the high-level steps for ACI access control. First and foremost, log on to APIC using your local admin account. Then create external authentication server provider. Then create external authentication server provider group. And finally, create your logon domain and associate your provider group to your logon domain. Last but not least, verify your configuration. In this lab topology, I have created two user IDs on my TACACS server. One is called admin that have full privileges in the ACI fabric, and the other one is admin-RO that has read-only privileges in the ACI fabric. So let me demonstrate you how to configure TACACS in ACI. As we discussed, folks, first you have to log on as your local admin ID to ACI APIC. Under advanced mode, go to admin tab. First, create the TechX provider. Over here, I have already created my TechX server with IP address 10.7.41.174. And I'll show you how to configure that. I chose authorization protocol as CHAP. I have given my TechX secure key and confirmed that key. I've used the default timeout and retry settings of 5 second and 1 retries. If you wanted to create your provider, you right click the TechX provider and create TechX provider. Over here you can put your TechX server IP address. Choose your authorization protocol. Insert the TechX key and then click submit. Okay, this is how you configure your TechX provider. Since we have already configured that in the past, I don't need to configure it again. After you configure the TechX provider, now you have to configure the TechX provider group. So right click that and click create TechX provider group. Give a name. Of your TechX provider group. Click the plus sign to select your TechX provider that you just created. Put a priority 1. You can put description as you wish and then click update. Click submit. Alright, now since we have created our TechX provider and TechX provider group, let's create the login domain. In order to do that, click on AAA authentication, browse login domains. You see a fallback over here. Make sure that the fallback is using local authentication, which is by default. Okay, now you create your login domain here. Name your login domain. Since we are creating TechX as our login domain, so we will choose TechX protocol for that. And over here you have to associate your TechX provider group that you created earlier in this demo. Click submit, and there you go. This is how you create your TechX in ACI Fabric. Let's verify that. As you recall, I have created 2 user IDs on my TechX server. One is called admin that have full privileges in the ACI Fabric. The other one is called admin-RO, and it has only read-only privileges in the ACI Fabric. Okay folks, let's verify our TechX user IDs. Let me log on using the read-only user ID first. As you can see, now it is giving us the option of choosing the domain, logon domain. So choose the logon domain that you have configured earlier and click login. All right, it let me log on to ACI APIC using my read-only TACX ID. I just wanted to show you that I do have read-only privileges using that TACX user ID. If I click here, go to AAA and check view my permissions. As you can see, I do not have write privileges with this user ID. I can further prove that out to you by going into admin tab, click on firmware, and try to upload a firmware in the firmware repository like what we did during our software upgrade demo. If I bring my mouse cursor to firmware repository, right click there, and as you can see, I do not have permission to do that step. It is grayed out. Let's see, go into Fabric tab and try to disable an interface of a leaf. So this is leaf 1 Ethernet 1/1 interface, which is up and running. If I right click that interface to try to disable it, there you go, folks. It's all grayed out. It will not let me do anything in the ACI fabric because I'm using TACX user ID admin-RO that only have read privileges in the ACI fabric. Okay, so now let's log out through this user ID and log back on using the admin user ID that have full privileges. In the ACI fabric. All right. Let me use the admin ID that I have created on the TACX server to be able to log on to my APIC controller. If I check the privilege of this user ID by going into AAA and checking my permission, and there you go, I have admin privileges to the ACI fabric using this TACX user ID, admin. Okay, let me go to the same admin tab and show you that I have full privileges with this user ID. If I right click the firmware repository, there you go, folks. I am able to upload firmware using this TACX user ID. If I go to Fabric, leaf 1, there you go. Now it's all available, all the options are available for me to exercise. All right, so this concludes configuring access control in ACI. Let's move on to our next topic. All right, folks, the last topic of today's presentation, configuring SNMP, syslog, and NTP within ACI fabric. SNMP version 1, 2, and 3, all of them are supported in ACI. SNMP can be configured either under tenant or under fabric policy or under access policy. If you have configured under tenant, then any event that gets triggered within the tenant you will get a trap via SNMP. Similarly, if you have configured under fabric policy, any event gets triggered within the fabric. Let's say your 40 gig link from a leaf to a spine uh, gets faulty, then that triggers an event, and you will get an SNMP trap uh, if you have configured this under fabric policy. If you have configured SNMP via access policy, then any access interfaces within the ACI fabric, if that gets up or down or something happens, an event gets triggered and you'll get an SNMP trap. SNMP configuration policy is fabric wide throughout the ACI fabric. Syslog, like SNMP, can also be configured either under tenant or under fabric policy or under access policy. NTP configuration is also fabric wide like SNMP through the pod policy. ACI fabric can only be NTP client and it cannot act as a NTP server. Here are some of the high-level steps for SNMP, syslog, and NTP. First and foremost, check the reachability of SNMP server from ACI infrastructure. Create SNMP pod policy. Associate SNMP pod policy to policy group to profile. Define your SNMP destination and select the appropriate management interface. In our lab, it is out-of-band management. Define SNMP source, and finally map your SNMP source with SNMP destination. For syslog, still need to check the reachability of your syslog server from your ACI infrastructure. Define the syslog destination and select the appropriate management interface. Define syslog source, and finally map your syslog source with syslog destination. For NTP, check the reachability of check the reachability of NTP server. My apologies, there's a typo here. From ACI infrastructure, create NTP pod policy, specify NTP server details and select the management EPG. Associate NTP pod policy to policy group to profile. Last but not least, verify all these configuration steps. So let's move on and configuring each of these features within ACI fabric. All right, let's configure the SNMP first. Go to Fabric tab, Fabric Policies, click Pod Policies, Policies, right-click SNMP, and create SNMP policy. Give the name for the SNMP policy. Click Enable to start the SNMP process. Define your contact information. Define your location. You can create your community policies here. In my case, it's public. Update. You can create client group policies. This is basically if you want certain management hosts to access your ACI infrastructure through SNMP, then you only allow those hosts to come and talk to your ACI infrastructure via SNMP. It's the same way, if you recall, in the traditional way of networking when we define SNMP ACLs. However, with ACI, you cannot define a subnet, a complete subnet or network to allow and access your network infrastructure via SNMP. You have to specifically define a network management station IP address to allow and access your rest of the network devices via SNMP. So here I am going to give a SNMP access policy here. Choose out of band management, client entries, so I'm only allowing this particular SNMP management station to talk and query my ACI infrastructure via SNMP. Click update and through the out of band management interface. Click OK. All right. Once you are done with your SNMP policy, click submit. Okay, so this is the first step, what we discussed earlier during the PowerPoint slide. Second step of configuring SNMP is to configure the destination address to send your SNMP traps to. For that, you click on Admin tab, go to External Data Collectors, click Monitoring Destinations, right-click SNMP, and create SNMP Monitoring Destination Group. Name your SNMP Monitoring Destination Group. Click Next. Click the plus sign. Put the IP address of your SNMP management station. In my case, I'm choosing version 2C. Community name, public. And I am using out of band management interface for SNMP traffic. Click OK and click Finish. All right, now let's go back to Fabric to complete the third step in configuring SNMP. Again, under Fabric Policy, Part Policy, we have already defined the policy SNMP here. Now we have to associate that policy to the policy group. In my lab, I already have a policy group called Part 1. So click there. And over here, choose your SNMP policy, which you created earlier. So auto SNMP and click submit. Click yes. So this concludes the SNMP configuration. I will demonstrate configuring syslog and NTP next, and at the end I will verify all three configurations before concluding this presentation. So let's move on configuring syslog. Let's first create the syslog server. For that, go to Admin tab. Under External Data Collectors, click Monitoring Destinations. Right-click syslog and create syslog monitoring destination group. Give a name for your syslog server. Admin state enable. Local file destination state enable information. Console destination enable and alerts. Click next. Click the plus sign to add your syslog server address here. In my lab, I'm using the same server 10.7.41.208. Enable that. Severity information. Forwarding facility local 7, port 514, and I am going to choose out of band management for syslog access. You can name this server as well. It's up to you. Click OK. Finish. Now click configure the source for syslog. For that, you have to go to Fabric. As I mentioned, you can either configure it under tenant, monitoring policies, or under Fabric policies, or under access policies. So we're going to configure it under access policies. Click on monitoring policy. Click on default. Then click on call home SNMP syslog. Choose syslog. Define your syslog source. Minimum severity is information, and I would like to include audit logs, events. Destination group is your syslog server. Click submit. Similarly, you have to choose the source for SNMP. So click on SNMP, click the plus sign, name the SNMP source. Associate it with your destination SNMP server. All right. So we have successfully configured SNMP and syslog. Now let's configure NTP, Network Time Protocol. As I mentioned earlier, Network Time Protocol settings are also fabric-wide like SNMP. So for that, you have to go to Fabric, Fabric Policies, Pod Policy, Policies, click on Date and Time, click on Default to choose your time zone. I am in the Eastern time zone. America, Detroit. Offset state enable, and click submit. All right. Then right click your date and time to create your date and time policy. Name it auto NTP. Administrative state enable. I am not using any authentication for NTP in my lab, so let it be disabled for now. Click next. Click the plus sign to add your NTP server. In my case, it's I will leave the polling interval as the default. Not going to choose this as a preferred server because this is the only server I'm configuring, so no need to select that option. I am going to choose out of band management for NTP. Click OK and finish. Last thing, under policy group, under pod 1, make sure you select your NTP policy here, which you just created. Click submit. Say yes. All right, folks. This ends up the configuration of syslog, SNMP, and NTP in ACI. Let's verify our configuration now before concluding our presentation for today. All right, folks, let's verify our syslog, SNMP, and NTP configuration settings. So I have logged on to leaf 1. All right, as you can see, all the configuration that we made via Epic GUI, it is showing in leaf 1 with the SNMP management station IP address. Over here, port 162, SNMP version 2C, set for trap, and community string public. Right now, we got this many SNMP packets output and this many packets input to leaf 1. It is also showing the system contact and location of SNMP configuration what we gave via Epic GUI. So let's run this command again to see changes in the input and output SNMP packets. Right now it's showing 16182 output packets, 16192 input packets, as compared to the previous one, which was 16174. And 16184. So there you go, folks. We just verified our SNMP configuration, which we made via Epic GUI, and we verified it via CLI on leaf 1. Now let's verify our syslog configuration. For that, let me run a packet capture utility that comes handy on each of the leaf. It's called TCP dump, very well known packet capture utility. -I for defining the interface, Ethernet 0, -F for defining the port, 514 is the port for the syslog. So let's initiate the packet capture on leaf 1. Let's go to leaf 1 and I will disable an interface on leaf 1 and show you a syslog gets generated out of leaf 1. There you go, folks. So your syslog is also working fine. Let's come out of this. Now let's verify your NTP server. Show NTP peer status, and as you can see, it is talking to NTP server 10.81.124.160 in client mode. Okay, let's use the same packet capture utility to see the leaf is working fine, talking to the NTP server. TCP dump -I Ethernet 0 -F port 123 for the NTP server. So let's see if leaf 1 starts communicating with NTP server or not. There you go, folks. Leaf 1 started talking to the NTP server. So this confirms our NTP configuration in ACI as well. Let's come out of this. All right, folks, this concludes my presentation for today. I hope you enjoyed the video and have acquired enough knowledge to manage your ACI fabric. I will bring more of these videos on demand on ACI technology for you in the future as well. Until then, goodbye to you all. Thank you very much.